Hi everybody, how are you? I just thought I will make a little video to explain how to go about drawing these diagrams for reflection of two-dimensional waves. So these are questions you're expected to do and they are on page 13 in your booklets. So I thought I'll just take you through question 1. So the diagram looks like this, and what you're given is, so these are your wavefronts, okay, the incident wavefronts, and this arrow is the direction in which these waves are moving. So the first thing you have to do is take a ruler and you need to kind of extend this arrow till it meets this black line. That is where it reflects. So this arrow stands for the incident ray. And the reason you have to do that is you got to find out where does the incident ray hit the surface. Once you know where the incident ray hits the surface, then you can decide where to draw the normal, and the normal is always drawn at 90 degrees to the surface. So I've just done that for you. So here we go. Okay, so the blue lines are the wavefronts, the black line represents the surface where it hits, and I've kind of extended this red arrow, that's the ray, to touch the black line, and wherever it touches you've got to draw the normal. That's my green dotted line and it should make 90 degrees. This is your angle of incidence. So once you've determined that much, then the rest becomes quite easy. So I've just taken off the blue lines, I'll put them back in a moment. So this is your incident rate, so that was already given. That's the normal that you've drawn. Kind of make out that's your angle of incidence. So now you've got to get your reflected ray, because that tells you which way the waves are going to go away after hitting this. And just make sure these two angles are the same. So how do you draw your diagrams? I've got them all here, color coded for you just to make it a little easy. So there's your surface, there's your incident ray, that's your normal which you drew, that's my angle of incidence, and I drew my reflected ray with my angle of reflection. So all that I have to do is, at right angles to the reflected ray, I just have to draw my reflected wavefronts. Okay, so just be careful here. The wavelength doesn't change, so the distance from one green line to the other is your wavelength, which should be exactly the same as how fast-paced the blue lines are. So the wavelength of the incident waves is the same as the wavelength of the reflected waves, because there is no change in speed for reflection, there is no change in medium. The only change that happens is a change in direction of movement, because when it gets reflected. So I hope that made sense. Okay, bye for now.